Okay, so for our last few problems here, we're looking at problems 17 through 20. And so let's start with 17 here. It says graph 1 or graph 2. So basically we're going to be looking at this graph, seeing if that is being described by the words down here or if it's graph 2. If you'll notice real quick, there are some significant differences. Graph 1, here we're dealing with a positive force. Here the force is negative, so it's either moving from the right to the left or it's moving down. The direction of that force is either to the left or it's down, and that's what makes it a negative force and what causes the differences. So 17a shows an object with a positive acceleration. Well, if the force is negative, then the acceleration can't be positive, so this would have to be graph 1. Could be an object moving to the right and slowing down. Well, an object that's moving to the right and slowing down would be one that has negative acceleration. So this was moving to the right, but we see that since it has a negative force being applied to it, it's slowing down. So this would be 2. Yes, this object could be moving to the right, but it can't be slowing down because a force is being applied all the way until 4.5 seconds. So that's actually accelerating it. It would be speeding up. C shows a negative change of speed. This would be 2 as well, because any force would be a negative change. And D shows a shows a force pushing to the left. This would be 2 as well. So remember, it's to the left. This is the direction of this force. Could also be down, but that wasn't one of the choices here. Okay, so that's how we do the first here. And once again, just remember for this one that the force is negative. Okay, number 18. Here we're talking about, is it the force at A, B, C, or D, and there could be more than one. So what is the strongest positive force? Well, the positive forces are all on graph 1. The strongest one would be here at B. What is the greatest negative force? Once again, this is pretty easy. Just right here at E. The weakest positive force, which one would that be? It'd be here at C, because that's only at 1 Newton. What will cause the fastest negative acceleration? The fastest negative acceleration would be caused by the greatest negative force, so that would be E as well. Okay, is the strongest force pulling left? Strongest force pulling left. So which one would that be here? Strongest force pulling left would be E as well. And it shows negative acceleration. This would be both D and E, because D is negative. It's just not the greatest. It's not the most negative, but it is negative. Okay, let's scroll down and answer questions about 19. Well, let's see if we can make it work with the space that we have. So we're supposed to find the impulse of graph 1. Okay. Impulse, remember, is the area under the curve of the impulse graph. So all of this area under the impulse graph is the impulse. You need to find what that quantitatively would be. So how we do that is we basically say, let me use this feature here. We're going to find the area of this rectangle, and then we need to find the area of this triangle, and the area Now we know that the area here, so it goes up 5. Okay, so in the middle it's 5, and it's 3 seconds in length, so the middle part would be 3 times 5. That's for the rectangle. And then there's going to be 2 triangles, which, remember, triangles are 1/2 base times height. Here it's 1 times 5. On this side it's 0.5 times 5. And when we do all of the math from that, so we get 2.5 plus 15 plus 1.25, the answer is 18.75 kilogram meters per second. So that's the answer for that. Over here, a 2 kilogram object is moving 6 meters per second. What would be the final velocity of it after the impulse of graph 1? So its initial velocity, or initial momentum, would be 2 times 6, 12. It's going to experience an impulse of 18.75, which means that its final momentum is going to be 30.75. That's not our answer, because we're looking for the final velocity. Remember, it's a 2 kilogram object, so if we divide that by 2, then we get our answer, and our answer is that V is going to be equal to 15.375 meters per second. And that's it.